Okay, let's try and prove this now. So we're given two triangles that are similar. So we'll say we'll have one large triangle here, I'll just call this is the point A, and this is angle A, and this is B, and we'll call this C, and then we'll have the smaller triangle here, D, E, F. So you're given that they're similar, then their sides are in proportion. So to be similar means that the angles are the same. So that is angle A equals angle D, angle B equals angle E, and angle C equals angle F. Okay. And we're required to prove that AB over BC, that would equal DE over EF. Okay. Or no, sorry, that's wrong. I just realized. Yeah, to show that they're in the same proportion, we need to show that AB over DE equals BC over EF equals AC over DF. Yeah, that's it. AB over DE, BC over EF, and AC over DE. Okay, actually I wrote that out a little bit too big, so let's try and squeeze the proof in here. So what we need to do in the original triangle ABC, mark off an M such that AM is the same length as DE. And also we'll mark off an N here such that AN is the same length as DF. And then we'll connect that up. Okay. Now, the triangle here, AM, and so the length AM equals DE and the length AN equals DF just by the construction of M and N. Also, angle A equals angle D. So this angle up here, which is angle A, we know that's the same as angle D here. So what we can say is that this little triangle here that we've just put onto the bigger triangle, that's congruent with this triangle here. So that means the triangle DEF is congruent to the triangle AMN. Okay. Next now. We would be nice to show now that this line MN is parallel to AB, and we can do that because the angle here, let's call this angle M. The angle M is equal to the angle E, which is equal to the angle B, which is then here. We know M is equal to E because they're congruent, and we know E is equal to B because they're similar. So this is because they're congruent, and this is because they're similar. And because these angles are equal from the earlier theorem, we know that MN, that line, is parallel to BC from the earlier theorem, one of the ones we did earlier. Okay, so we know that these lines are parallel then. Good. Okay, we're making progress. So that means then I'll have to make a little bit of space. Oops. I'll just remove this here just to make a bit of space. Okay, because I'm nearly finished. Just continue it up here. Oh, I can't remember the name of the theorem, but it says that, you know, if this is parallel to this, then it means that this and this here is going to be in the same proportion as this side and this side here. And I can't remember. That's not a theorem I've done recently, but that's an earlier theorem that can be used, but not one that I've done recently. So that means then that AM over MB, that will equal AN over NC. Okay, getting closer. AM, that's, oh, yeah, that was the same as, oh, I removed the triangle. That was the same as, I shouldn't have removed the triangles. What did I have originally? It was like this, ABC, wasn't it? And then the smaller one here was DEF. So AM is the same as AE. Okay. And then that's MB. And that's equal to AN, which is the same as DF over NC. Okay. Nearly there, nearly there. Oh, you know what? I've just realized I've written this down the wrong way. That's making my life a little bit harder. Sorry. It's more normally stated as this length compared to the total length is the same as this length compared to the total length. That's what the theorem properly says. So I should have started off by saying AM over AB, that's equal to AN over AC. Okay, that's good. Now AM was the same as DE, so DE over AB, that's equal to AM, which is DEF, I think, over AC. Okay, let's see. I've got an AB I'm happy about, and I've got a DE, and I've got a DF and an AC, but it's just upside down. So if I just flip these upside down, AB over DE, and that's equal to AC over DF. Okay, so I've shown that this one is the same proportion as this one. And the logic follows true for getting the last one as well. So I think they're happy to let you just say and likewise for the last one, because you've shown that two of them are the same. So, and likewise, you can say BC over EF, which I know seems like a little bit of a cheat, but I mean, if you want to prove it, you can, but it's okay just to make that last jump like that.